Okay, let's talk about distortion. So this plate, has been shot on a lens, which is a 35mm lens, and it suffers from something we call lens distortion. So that means that straight things in the plate will be represented as curves. So we have to be really mindful of that, because when we do a 3D match move or a camera track, what we're doing is we are representing 2D points in 3D space. So if the 2D representation of those 3D points is skewed by lens distortion, it means that our match move scene will not fit the plate. That, in reality, that means that items will skid around on the surface, they will drift. We will never be able to get things to stick perfectly to this plate, and that's our aim, is to get things to stick to the plate. So what we must do first is undistort the plate. Now, I must preface this by saying that Nuke has a little bit of a strange workflow for doing this. In other software, like dedicated match move applications like PF Track and 3D Equalizer, this is something you don't have to worry about as much in this order, but because we're using Nuke for our match move, we have to do this in a really specific order. That means that we have to solve our lens distortion first, then do our 2D tracks, and then our 3D solve, in that order. So let's have a look at how we can solve our distortion. And this is the setup here, and what I'm going to do is just borrow these nodes and start again on this left hand side. So what do we have? We've got two plates, and let's have a look at the length of these. You can see these are very long plates, and they are of a lens grid. So we've got two plates here. So what we need to do is find parts of these plates which are going to work well as distortion grids. And let me just illustrate some of the effects of distortion. So I found a frame on this plate on read 3. So because I like the look of this frame, I'm going to put a frame hold on it and set it to this frame. So we'll just concentrate on this frame for now and have a look at the distortion of this lens. So out of the box, it doesn't look too bad. If I asked you if that grid was straight, if the lines on it were straight, you'd probably say yes. However, our eyes are not very good at measuring this. So a little trick that we could use just to assess this is just to use a rotor node with a standard Bezier. And the idea is that I know that this grid in real life has straight lines on it. So if I just draw some straight lines using a roto shape across this grid. Now I realise this is probably quite disorientating and horrible to watch. What we may find is that these lines are actually bent. Only very slightly, but they are not straight. So let's just line that up with a corner. What we'll find is that this checkerboard will start to bow in the middle. So you can see I've got this point here right on the corner, and as we get to the center of the frame, the checkerboard grid tends to deviate from that straight line. It bends up in the middle. As we get towards this edge, it will start to flatten out again until we get to this corner, which I'll just adjust a little bit so you can see this big bow across the middle. We're going to see a similar thing happen at the edge, Let's just check that we've got this right on the corner. Again, as we get to the edge, this plate starts to bow inwards or outwards a little bit. So that is the effect of lens distortion. And what we'll find is that it's stronger towards the edges of the plate than it is in the center. So we may find that if we draw a straight line pretty much directly through the middle of the image, we're not going to get much, if any, deviation. So that's a line roughly through the center, barely any deviation. So what we're going to find is that there's very little distortion in the center of the image, and as we move towards the edges, we're going to get quite a lot. Even the difference between this sort of inner ring around here versus lines which are a little bit further out towards the edge, these are going to have much stronger distortion. So although I can't pick an edge around there, what we should find is that if we look at these top lines, we're seeing a lot more distortion literally in this space here than we are here. So much stronger towards the edge. Now the effect that this has is, if we look at our comp, anything that's close to the edge of frame, so this teacup or this grey ball right on the front of the frame here, if we don't solve the distortion in our workflow, it's going to be difficult / impossible to get this grey ball to appear as if it was stuck on the surface of the table without it slightly sliding around on top of itself or looking like it hasn't been properly tracked. The same with anything towards the edge of frame here. That's going to have the same effect. It is much easier to get things to stick to the middle of the frame. There is still a tiny bit of distortion in the middle of the frame, but it's much less than the edges. So we know that our frame has distortion in it, so how do we solve it? Well, we use a node called LensDistortion in Nuke. So if I press tab and type lens, and I look for LensDistortion, which is a transform node, I will get this node here. It's called LensDistortion. So this LensDistortion node can solve lens distortion from a checkerboard image quite effectively. It expects to be given either a single frame, and because I've got a frame hold on this frame that I've picked, this is going to be quite an effective frame to use, or we can use multiple frames. So I'm going to show you the single frame example first, and then I will show you how to do it with multiple frames as well. So with a single frame, it's fairly easy. We go into the Analysis tab, and we press Detect. Now this is going to make a keyframe. Although we're only dealing with one frame, it's important to recognize that this is going to make a keyframe within our global range. So take care about which frame you're currently on. I'm on the first frame, 1001, and I'm going to press Detect. This is going to detect every single intersection that it finds on the screen, and it's going to draw lines between them. Now what we have to do is just manually sanity check each of these to make sure that there are no outliers. So where we're going to find that, and what I mean by outliers is any anomalies I should say, not outliers. So I'm homing in on this point here, which is, because it's really close to the edge of frame, Nuke is liable to make a little bit of a mistake with this. You can see it's got it just slightly wrong. So to be safe, I'm going to drag select that point and hit delete to delete it. And what I want to do is just make my way around the edge of this image and just check that none of the points are in unreasonable places. And yet this is probably very sickly to watch, so I apologise. This all looks good so far. I want to just have a brief check of the centre of the frame just to make sure there's nothing else going on. And the way this works is it draws crosses or points on every intersection and then draws lines between them. So what it's saying is that this is supposed to be a straight line. This node is trained to work on grids like this, checkerboards. So once we've got a frame which has been covered with valid points and valid lines, we can move on. What we're going to find is that when we solve multiple frames, there'll be a lot more cleanup to do, but this has given us a fairly easy thing to get on with. So once we've drawn one set of grids, we can click on solve, and that is going to solve the image. Now, there is a really unhelpful thing that goes on here. Notice how if I disable this node, it undistorts the image, but it also makes the image grow slightly. It makes the image slightly bigger than the original format. So we need to solve that. And the way we're going to solve that is with a crop node. Because what we don't want to happen is, we don't want to lose any of this information. If you take note of this intersection here, and if I just turn, I can't really turn these overlays off, but if we look at this intersection here between these two white squares and these two black squares, notice how they get moved up to the top right of the frame, and this section here, like these pixels on the edge of frame that I'm trying to highlight, they get bumped all the way up to here. So that means we've got parts of the image which are being hidden behind the format, which is really bad news. If we were to continue working like this, we wouldn't be able to trace our steps back and work on our whole project effectively. So what we need to do is expand this format to be the same size as the undistorted plate. So what we have to do is make a crop node, and I'm going to turn off black outside. That prevents it from adding extra pixels around the edge. And what I want to do is I want to copy, so I want to copy these values here, 2064, 1090 and -17 and -10. So those numbers need to go into these boxes on this crop, and that is going to effectively set this crop to be bigger than our format, like this. I'm doing it kind of manually now, so it's going to be something like that. Now, the slightly dodgy thing about doing it manually like this is, or typing these numbers in, is it isn't very robust for when you're working with multiple resolutions or if your lens distortion model changes slightly. So to mitigate this, what we do is we use an expression instead. So on our crop node, all we have to do is press this little squiggly line here and go to add or edit expression. So what we need to do is reference these numbers, this -17 and -10 and 2064 and 1090. We can reference these numbers by accessing a tiny piece of code which is bbox. So if I type the word bbox in here, bbox refers to the coordinates where this bounding box, this dotted line, is located. So what I want to do is reference the bbox x, which is this corner here going in the left direction, or the x direction. So if I type in here bbox.x, it's going to reference that value, -17. All I have to do is fill in the rest of these boxes with y, r, and t. So bbox y, bbox r, and bbox t. So you can see that's going to fill in -17, -10, 2064, and 1090. It's now automatic. Okay, now the absolutely critical part of this, which often gets overlooked, is that we have set the new bounding box, or the new format, and now what we need to do is tick this reformat button. This is the most important part of this whole setup. And watch what happens. If I zoom in on this top corner, you will see that we now get back this top corner of that checkerboard. So that's the difference with reformat turned on. The result is that we get an image which is now undistorted, as well as the format being stretched to accommodate it. So we get this new format, which we have to render at. We have to now render our CGI at this format. This is our undistorted format. So in our case, our undistorted format is 2081 by 1100. So what I would do with this now is I would use this as a kit of parts to undistort my footage. Now the slightly sort of off-putting thing about this LensDistortion workflow is that what it will do, and if I zoom in right here, you may be able to see that it stretches the pixels along the top. It's probably easier if I put it on that. So it stretches those edge pixels. It may be more helpful visually for us to interpret this if we could see black in those areas instead. So if we put a black outside node in here, that is going to black out those top edges and side edges. See that? So it just puts a little bit of black in the edges, and you can see towards the corners the original plate is going to nearly touch this corner, and as we get into the middle of the shot it's going to be a lot higher. So what we would do is draw a little box around these. Oops, didn't mean to do that. This was meant to be a backdrop node. And now this little set of nodes is our undistort. So this little setup here, we're going to copy and paste around this script once it's done. So that's doing an undistortion on a single frame. In the next video we're going to look at doing it on multiple frames to get a little bit more of a rounded result.